All right, this is lesson 6-4, solving systems of equations by elimination when we have to use multiplication with it. Okay, so if you'll recall in the last video, 6-3, we used elimination by adding or subtracting two equations together, and in that process, one of the variables gets eliminated, gets canceled out. And then we can solve for the other variable, and then use substitution to go back and solve for the one we had canceled out originally. That sounds confusing. So in this case, we're still going to use that same method, but it doesn't seem quite as easy because none of our leading coefficients match, right? So the x and the 4x don't match. They don't have the same number in front. The 10y and the 5y don't match. So we can't really add or subtract to eliminate either of these. So in this case, if you have to use elimination and nothing matches, just pick one of the variables you want to eliminate. So I can either pick x or I can pick y, it doesn't really matter which one. And then you're going to ask yourself, okay, what do I need to do to one of those numbers to get it to match the other? Okay, so you want to try and pick whichever option you're going to use the smallest multiplication numbers, right? So I could make this match this by multiplying by 4. And I can't just multiply x by 4. I'd have to multiply this entire equation by 4. But in doing that, my x's would match and they could cancel. Or I could multiply the bottom equation by 2 and then my y's would match. So what's smaller, multiplying by 4 or by 2? By 2, exactly. So we're going to multiply by 2. So I'm going to multiply this equation by 2. And then they're going to change. So the top equation doesn't change. It stays x plus 10y equals 3. The bottom equation changes. So 2 times 4x is 8x. 2 times 5y is 10y. And 2 times 5 is 10. Okay? And we didn't change the value of this equation. It's still the same equation. We just made it look a little different. Just like when you change a fraction from, like, 2/3 to 4/6. It's still the same fraction. We just made it look different. So same thing here, but now my y's match. So now I can use elimination, okay? So they match. They have the same sign. So I'm going to subtract. X minus 8x is negative 7x. 10y minus 10y is 0. And 3 minus 10 is negative 7. So I have negative 7x equals negative 7, divide by negative 7, and x equals 1. Once I have my first variable, then I can just go back and plug it into either equation, doesn't matter which one, and solve for the other variable. I'm going to plug this into the first equation. So 1 plus 10y equals 3, minus 1 from both sides, 10y equals 2. Divide both sides by 10, and y equals 2 over 10, or 1/5 when I simplify. So my solution is 1, 1/5. Okay, that's kind of a lot of steps, but hopefully that makes sense. So the entire elimination using multiplication just hinges on us picking one of our equations, sometimes both. We'll do an example of when you got to do both, but multiplying to make the equations look different so that one of my variables or one of our variables matches. Okay, so let's do a couple more. Next one, let me try and find one. They all have the exact same numbers. All right, let's use 2x plus 3y equals 6, and x plus 2y equals 5. All right, so obviously the x's don't match, the y's don't match. I can either multiply, I have to multiply both of these to get the y's to match. I can multiply this by 2 and this by 3, which you can do, but we don't have to because I could just multiply the bottom by 2 and the x's would match. So I'm going to multiply the bottom equation by 2, and then I'm going to get, top stays the same, 2x plus 3y equals 6. The bottom becomes 2x plus 4y equals 10. Remember, you're distributing that 2 to everything. And now my x's match, so I can either add or subtract them together, right? They're both positive. They have the same sign, so I'm going to subtract. If they were different, if one was negative, one was positive, then I would add them. Whatever I have to do to get them to cancel each other out. 2x minus 2x is 0. 3y minus 4y is negative y, and 6 minus 10 is negative 4. So I'm going to divide both sides by negative 1, and I'll get y equals 4. And once I know what one variable is, I can just go back and plug it in to find the other variable. X plus 2 times 4 equals 5. X plus 8 equals 5. Minus 8 from both sides. X equals negative 3. So my answer here would be negative 3, comma 4. Don't forget to write your solution. If you just leave these boxes here separate, you're not done. There is no answer for me to grade if you don't have an ordered pair here, so you just wouldn't get credit for it. You have to finish it with your solution. Okay, let's do another one. Let's see if I can find one where we have to multiply both. These are all kind of easy, so you don't really have to multiply both. Oh, there's one. Okay, let's do 3x minus 2y equals negative 7. 2x minus 5y equals 10. Okay, so here, the x's don't match, the y's don't match, and I can't just multiply 3 by something to make it 2, or 2 by something to make it 3. Same with the 2 and the 5. I can't multiply one of them to make it match the other. Excuse me. So I am going to multiply both, right? So now, doesn't really matter which one I'm multiplying, I just want to multiply by the smallest numbers possible. So if I need to make my x's match, I have to multiply the top by 2 and the bottom by 3. If I want to make my y's match, I have to multiply the top by 5 and the bottom by 2. 5 is the biggest number, so I don't really want to deal with that. I want to deal with the smaller numbers. So I'm going to multiply this top equation by 2 and the bottom equation by 3. And when I do that, my x variable is going to match, okay? So I'm going to distribute, and we're going to multiply everything in the equation by that number in front, okay? So 2 times 3x is 6x, 2 times 2y, or negative 2y, is negative 4y, 2 times negative 7 is negative 14, and then for this equation, 3 times 2x is 6x, 3 times negative 5y is negative 15y, and 3 times 10 is 30. Okay, so now I've got two equations and my one variable matches, okay? They're both positive, so to eliminate them, I'm going to subtract. 6x minus 6x is 0. Negative 4 minus negative 15 is really negative 4 plus 15, which is 11y. And negative 14 minus 30 is negative 44. Okay, and then I divide both sides here by 11, and y equals negative 4. Once I know what one of my variables is, I can go back over here to my two original equations, plug it in, and solve for x. I'm going to use I'll use the bottom equation. So 2x minus 5 times negative 4 equals 10. 2x plus 20 equals 10. 2x equals negative 10, so x equals negative 5. Okay, so my solution here is going to be negative 5, comma, negative 4. I hope that's making sense. It's a pretty quick video, but the idea is the same, right? Before we add or subtract using elimination, we have to make sure that one of our variables match. And you can't just multiply that one variable, because if I multiplied this and changed it to 6x and left everything the same, I just changed the whole equation, right? If I multiply everything by 2 here, and I change this to 6x, negative 4y, negative 14, then the equation is worth the same amount. It just looks a little bigger. As I said, just like an equation, or just like a fraction. If I had 1/2 and I changed it to 5/10, right? They're worth the same thing. It's the same fraction, one's just not simplified. Okay, so it's okay if it's bigger as long as you do the same thing to everything. Sometimes you can just get away with multiplying one equation to get variables to match. Sometimes you have to multiply both equations like we did in this example. So either one is normal. And then once you've found the first variable, then you just use substitution to go back and find the second. Okay, let me know if you have questions.